Thank you very much, Tamara. I'm happy to be here. It is kind of a challenge, and I was even thinking about this as recently as yesterday. I got here a day early to take a little time hiking up there near Lake Tahoe, and I went over, you've all been there, I'm sure, to the Desolation Wilderness, and I was thinking about this matter of forest disturbance when reading the sign at the trailhead that that particular wilderness sees more people per acre than any other wilderness in the system. And so right away, as I'm still trying to ponder what exactly I'm going to say to this group, I got to thinking about the conflict we have between trying to protect forest ecosystems in some system of reserves versus the other side of exploitation and the enormous amount of value there in timber resources, for example. And there was this line very clear on the ground as you entered the wilderness boundary where there had been a fire, prescribed wild, I'm not sure, and a salvage operation, so lots of stumps. And then immediately a boundary into the natural area, which is wilderness. And so right away I'm struck by how difficult it is for us to protect forest resources in some system of reserves when it's obvious that safeguarding any ecosystems from humans is really impossible. And really, in order to protect natural systems requires enormous amounts of human intervention. So we find ourselves in a very difficult and challenging time. And I believe the real challenge for us as managers and scientists is to transform what I see as a crisis into an opportunity and try to translate science into policy at some relevant scale. And that is a large challenge. If you think about forests in the Northwest, for example, let's say the Northwest Cascades of Oregon, Washington, and the whole idea of old growth. I mean, old growth is something that is central to the American psyche, as is wilderness. You know, nowhere else in the world is there wilderness with a capital W. It's a very special place. And yet there are foresters in the Northwest who would like to convert that to Douglas fir plantations that grow on a 60 to 80 year rotation. And I'm somewhere between that. I have a forestry background, and I very much have a romantic attachment to old growth and natural forests. Consider also tropical forests, the richest and most diverse expression of life ever evolved on this earth. Somewhere between half of the world's 10 to 100 million species of plants and animals exist in tropical forests, where there's this system of interlocking and interdependent connections between the biota and the physical environment. And yet these are easily manipulated and destroyed. And I think we need to regard tropical forest destruction as permanent and irreversible. You know, I am, as I have admitted, a forester. And one of the earliest foresters in this country who went to the Yale Forestry School established by Pinchot and Roosevelt in the early 1900s was Aldo Leopold. He was, in fact, a forester by training and in practice. He was also the father of wildlife biology in North America. And central to his philosophy, as expressed in many of his writings, was the land ethic, in which he proposed an intrinsic value to all biota that exists in the natural world. And I think we, as natural resource managers at some level, all kind of relate to that. And for me, the contemporary expression of that is called deep ecology, which is a philosophy that tries to look at and emphasize the interdependence of humans and non-humans' life and non-human life and how we must all interact at some scale if we're going to preserve biota on this planet. And I think just as quantum mechanics transformed classical physics as proposed by Newton and Descartes from a system of linear cause and effect macroscopic interactions into one in which there's the possibility to affect elements in the universe infinitely far away by observations and actions that we have here today. But just as quantum physics transformed mechanical physics, classical physics, so too can deep ecology transform the way we look at forest ecosystems. I'm trying to use the symbolism or metaphor of Indra's net as an idea to look at these interrelationships. Because Indra was an ancient Hindu god who, I believe it was a woman in her infinite capabilities, was able to stretch a net from all corners of the cosmos. And the strands within the net are connected at pearls or dewdrops. And each of these pearls, I'm sorry, this might be giving you like a migraine or something. Try to look away. But it's kind of the best I could do to symbolize something of an unfathomable infinite scale in a PowerPoint slide. But think of it in words of a Buddhist philosopher, Alan Watts, who looks at these as individual dewdrops, and each dewdrop reflects the image of every other dewdrop ad infinitum. And that's kind of the symbolism I would like to use going forward with this talk. You know, we've understood the fundamental concepts of ecosystem management really for decades. I think the term ecosystem management, I kind of remember it being coined early in my career, like the be-all, end-all. And I think we know a lot about how it is we should try to manage ecosystems and how we understand the connectivity of organisms within ecosystems and the connection of organisms to the physical environment. But for me, as a forester, I really feel that by studying trees as individuals or as members of forest communities really adds important meaning to this from an ecosphere perspective. Because all plants, but I think trees in particular, because of their longevity, connect the geosphere with the atmosphere and interact with the hydrosphere to take water from the soil and connect it or combine it with carbon dioxide from the atmosphere to produce carbohydrates and, fortunately for us, oxygen. So they are really enormous, important reservoirs of carbon. Carbon sequestration is the modern parlance for that particular thing, but there are enormous amounts of carbon in forests worldwide, and they play an important function on regulating climate. Temperature, moisture relationships in forests are much different than that same place would be in the absence of that forest. Well, really getting to what I do at Utah State University as a disturbance ecologist is to look at interactions of agents of disturbance and how they interact over large spatial and long temporal scales. And so for purposes of this talk, I've limited it to bark beetles, forests, and fires primarily, and try to look at this from an ecological, biological perspective, what that means from a socio-political standpoint and management, and then how we might translate that into ecosystem conservation. And I picked these particular elements because of the fact that they are influenced so dramatically by climate, by drought. As in the previous talk, Mike Kelly talks about how a daily change in one of these might affect an insect or an insect population or a tree. But more importantly, how does it connect this interlocking web that puts this organism in its place in the cosmos? So we'll zero in on this individual pearl I'm calling disturbance events and talk about these particular elements here. Stand replacing fires, bark beetle outbreaks, the interaction between the two. If you think of a bark beetle outbreak, hopefully you've all seen one. It's hard to go anywhere without seeing one, I guess. You can appreciate the dramatic influence that this outbreak has on fuels and the likely extension for what that might mean for fire ignition and spread. And then fire wounding is kind of another aspect of that, how a wounded tree becomes susceptible to a bark beetle outbreak. And finally, this fuel alteration issue. So one thing that strikes even the casual observer immediately is the scale over which these agents operate. And there's no possible way for me to conceive of managing these influences without recognizing this scale. And that has very important social implications that I'll get to. The other thing is, I came in the room this morning and encountered Tamara and Todd there, and right away they began to sort of apologize for the smoke in the air. You know, welcome to Reno, it's usually much less smoky here. Well, where there's fire, there's smoke. And I think the thing that will most limit what we might propose to do in managing fire to deal with these influences is the smoke. You know, worldwide, prescribed burning, biomass destruction in the tropics, large amounts of carbon into the atmosphere. And if you're a legislator, are you going to propose restrictions on those automobiles going by on this interstate? Or the prescribed burners are up here somewhere starting fires, you know. So pretty clearly we're going to be increasingly constrained by managing smoke from fires. So again, it's the scale. You know, bark beetles are native insects. There are galleries of bark beetles found in wood samples from the Paleozoic, you know, a couple 100 million years ago. Quite a co-evolutionary relationship between beetles and trees. Beetles provide many important ecological functions in forest ecosystems by recycling all of that carbon and biomass back into the system. Forests are unique in where they grow and the fact that they have thick organic matter layers, and a lot of that is bound up and unavailable to other plants and animals. You know, fire beetles is a dramatic influence in how quickly that material can be recycled. You know, this picture is from Yellowstone I took in 1988, and I was counting on my fingers as I was hiking yesterday, and yes, 25 years. It seems like only yesterday, but here we are 25 years later, and this was a dramatic, high-intensity stand replacing fire. You know, even Ronald Reagan awoke for a couple of minutes to say, "Nancy, I think something's burning." I don't want to get into politics, sorry, especially here in Nevada. But yeah, something was burning, and it was this huge uproar. But take a look, as you probably have, at Yellowstone today. Took this picture just last year, 25 years later. I mean, this is beautiful to me. These are trees, you know, 25 now years old. And what out here looks like a putting green is wall-to-wall lodgepole pine. You know, there's nothing better for an ecosystem than to have a lodgepole pine forest ecosystem, to have a large stand replacing fire at some interval. And it happened over the scale at which these things need to happen in order for them to have some ecological significance. Well, one of the things I study is bark beetles, fuels, and fire accumulation. So this is in spruce. I have to remain shackled to this, you tell me, otherwise I would be wandering. But I'll hold on to this. It goes against my grain, kind of. We have here stand structure. These are Engelmann spruce stands. We have surface fuel complex and the condition of the foliage over the endemic, so few beetles per hectare. The epidemic, lots of beetles, 90% of the trees being killed. And then the post-epidemic, the population has crashed. So in the endemic situation, we have lots of big living green trees with pretty low levels of surface fuels and a large average diameter of those standing trees. In the outbreak, most all of those large green trees are killed. And so now we have a lot of dead trees. The diameter of living trees is greatly reduced, as is the number of living trees. And you can see the changes to the fuels complex as well. And then finally, in the post-epidemic, we have lots of dead trees, some growing smaller trees that weren't attacked. And importantly, this shrub component, which is reflected here, has a significant increase in the amount of shrubs in the post-epidemic. So really rapid change over the course of maybe 10 years in the composition and structure of this system. What does that mean for fire behavior? Well, there's periods within this time frame now where there's an increased potential for high intensity stand replacing fires. Early in the outbreak, when there's red needles in the canopy, there's a much greater probability of a surface fire ignition and canopy fire spread. Once the needles fall off, that potential is greatly reduced in this period here. And then reemerges later as we get into the period of dead trees sharing the site with the regen. So let me just go back. Here's the period of crown fire flammability like here. And then here we're in this period because of the shrubs and the lack of foliage of a reduced probability. And then here, the snags from the outbreak sharing the site with the regeneration is another period of enhanced flammability. And all of this you can imagine, I'm letting you use your own imaginations about how drought plays into this, but it obviously does. And largely in this particular system, it plays into the equation through the effect on 1,000-hour fuels. So 1,000-hour fuels are logs greater than 3 inches in diameter. And they take 1,000 hours to dry out. And they really only dry out during periods of drought. And when it's not drought conditions, they don't really contribute much to fire line intensity. But in periods of drought, these large fuels dry, and they contribute a lot to fire line intensity. So we can have more intense surface fires, much more difficult to control, much more dangerous for firefighters, much more ecological consequence. And if we look at the accumulation of 1,000-hour fuels over time, over a couple of different tree fall scenarios, we don't know really the rate at which the dead trees fall, but 1, 3, or 6 snags per acre per year falling gives you this kind of accumulation of fuel. So here we had an outbreak. The outbreak was in 1920. This particular picture is in 1948. So 20 years later, 40 years later, 60 years later, all the snags have more or less fallen. And then in year 2010, I took this picture. So there's this period, I mean, we're talking about decades to centuries where the influence of a bark beetle outbreak is important. And these episodes of drought can contribute to fires in this system, because in these spruce systems, often fire's not a major player because they're high elevation. There's lots of snow. The fire window is relatively small in most years. And so this particular set of photos taken at this place called Purple Lake shows the outbreak that occurred in 1902, in which 80% of the trees were killed, and the same place in 2002. And you'd be challenged to see how different this is. Well, it really looks very much the same. 100 years later, no fire happened. The trees that weren't killed by the beetles grew back, and we have this sense again of an old growth forest. Kind of skip over some of this, I think, in the interest of time, and move into management. I think we are, not only as managers, but as researchers, I think agencies tend to put us into little boxes. It really inhibits our ability to work together and to appreciate interrelationships and collaboration. That is true of researchers as well, so I'm not meaning it as a criticism. The intelligence community, there's an oxymoron, they're talking today about stovepiping, right? Where the agencies aren't sharing their information. And I believe in agencies with specialties, it tends to create competition for dollars and resources. And that's really has affected management. But here are some of the main things we do for managing forest health against bark beetles. And this is the Elizabeth Paul tree. It's near Kemmer, we say Kemmer, Wyoming, which is very near really nothing. But sorry for those of you from Wyoming. I love Wyoming as I love Nevada. But it reflects the importance of protecting the individual tree. Because here's a tree that from the eyes of a forester needs to have been gone decades ago. This is a dwarf mistletoe infested tree that's been attacked by Boy Scouts and every other thing, pioneers on the trail, I've carved on it. And yet, it's an important archaeological feature. This young woman died in childbirth, was buried under this tree. And no forester on that ranger district wants this tree to die on his or her watch. And so they're always asking, are the bark beetles going to kill this tree, I say, well, yeah, eventually they're going to kill this tree. But okay, well, wait till I get transferred. But it really reflects to me the importance of saving the individual tree and not seeing the forest for the tree. If it's the individual tree growing on your grandma's front yard, you'll spend enormous sums of money to protect that tree. It has, immeasurable value, as does the Elizabeth Paul tree. But it forces us into this. And forest health protection, no offense to any of you that are here, I live with a woman who works for them, spend a lot of money on spraying individual trees. This picture from the 1960s, spraying DDT, and this picture from the 2010s, spraying carbaryl. I mean, it could be the same exact guy. Let's put the guy in a white suit. Nothing has really changed. It's certainly the philosophy or the concept of direct chemical control has not changed. Similar to the use of pheromones. These are kind of individual tree treatments. And how do you manage those across this kind of a landscape? You don't. That's not to say that it's not important to protect the Elizabeth Paul tree, clearly it is, or grandma's blue spruce in her front yard down there in Reno. It is. But at the ecosystem scale, it just doesn't work. And we know what works at this scale. And it's this. It's creating the mosaics of age classes and mosaics of species that prevent host-specific insects from wiping out large areas of the landscape. And it's what fire did historically. Created the mosaics of age classes. The beetles don't attack trees less than about 6 inches or younger than about 80 years. So any, one-on-one forestry student could come up with a plan to manage mountain pine beetle and lodgepole pine in the West. You just break it up into age classes. But it has to be done over the scale of thousands to tens of thousands of hectares. And this clear cut was done in the 1960s, might be 40 acres. And it shows how clearly it works. This is all beetle mortality, and it's like they can't get in there because of the age class distribution. But you can imagine some forester putting in her NEPA document that she intends to clear cut 10,000 acres of lodgepole. They'll be coming out of the woodwork looking for this woman to hang her somewhere. So therein lies perhaps a thinning, logging. I start by saying destruction of tropical forests, and now I'm saying logging. There has to be some blend, but in order to manage forest disturbance at the appropriate scale requires logging.